FizzBuzz here. Today we're going to walk through the FizzBuzz problem on Replit, and I'm going to discuss the UMPIRE method, and we're just going to work through it all the way through. If you haven't taken a chance to do this problem, try doing this problem by walking through the UMPIRE method yourself first. If you get stuck, come back to the video, and once you're done with the FizzBuzz problem, take a look at this video and compare your problem-solving process with the process that we go through in this video. Okay, so the very first step in the UMPIRE method is understand. So what we need to understand is, what is the input? I'm in the Replit IDE, and so we have the prompt right here. So given an input, print all numbers up to and including that input. We're very explicit here, up to and including that input. Now, in the first video where I talked about understanding, what we wanted to do first was figure out what are the key actions here. So print is the key action here. We're not returning, we're not counting, we're not finding, we're printing. So that's the key action here, the key way we're getting output. What are we outputting? Well, all numbers up to and including the input number, unless they are divisible by 3, then print fizz instead. Or if they are divisible by 5, print buzz. If the number is divisible by both, print FizzBuzz. Now, we have a couple of example outputs, right? Given 5 as an input, so we don't have to come up with our example inputs. We can just mentally walk through the steps. So let's walk through those steps. For 5, what we'll do is we'll go, okay, 1, not divisible by 3, not divisible by 5. 2, not divisible by 3, not divisible by 5. 3, divisible by 3, print fizz. 4, not divisible by 3, not divisible by 5. Buzz, 5, not divisible by 3, but divisible by 5, so print buzz. These are the steps that we're going through. You can actually just take these as notes. Don't worry about the starter code that we've given you if you're not ready to solve the problem yet, and you just want to walk through it. So, for every number up to and including the input, is it divisible by 3? Is it divisible by 5? Those are the two questions that I'm really asking of every number. So is that number, let's get really specific here, is that number divisible by 3? Is that number divisible by 5? Okay, so we've looked through the first few numbers, but let's look at some of these larger inputs so that we can get to that. If that number is divisible by both, print FizzBuzz. With 10, we keep going. Fizz, 6 is divisible by 3, so we print fizz. 7 isn't divisible by either, so we print the number. 8 isn't divisible by either, so we print the number. 9 is divisible by 3, so it's fizz, and 10 is divisible by 5, so it's buzz. If we start at the buzz that represents 10 down here, 11, prime number, not divisible by 3 or 5. Fizz is 12, it's divisible by 3. And then 13 and 14, both numbers that are not divisible by 3 or 5. But then out here, 15, FizzBuzz. So let's just put this here. Is that number divisible by 3 and 5? So those are the main questions. Print fizz, print buzz, print FizzBuzz. So what I've done here is I've walked through the steps that are written out here, kind of mentally done that, identified what questions am I asking of each piece of data, and how am I going through that data. I'm just going number by number, so I've got this for loop here. So this is my pseudocode here, right? Now, up here in my starter code, I have def FizzBuzz, so we know that this is a function, and n is the input number. Okay, so that's given an input. Now, for current number in range 0 to n, what we need to do is look at this and check, okay, range 0 to n. Now, the range function only returns a list of numbers that goes up to n, but doesn't include it. That's something that's really important to note about the range function. So I'm just reading this example code and seeing kind of where does it compare to my pseudocode. For every number up to and including the input, there's a difference here, and it's really just the up to and including the input. So I'm just going to add 1 to n to make sure that we get to the input. So I'm going to go ahead and just comment that out because I've already taken care of that line here. Now, what we're doing is we're just printing the current number no matter what. And what we need to do is ask our questions. I'm going to just run this and see what happens. And for that to work, I'm going to need to comment this stuff out. And you can put this pound sign in front of your pseudocode so you can make sure it doesn't try to run. And then I'm just going to hit run. And I can see over here, I don't know if you can see, it just prints out each one of those numbers. I'm going to go ahead and go like this. There we go. So you can see each one of these numbers, right, is printed out. So let's just try with one of our questions. Is that number divisible by 3? So if is a good translation for is that number. If current number modulo 3 is 0. That's how we did that with the primes. If you think back in your matching stage, checking to see if a number is divisible by any other number, this is how we did that. But we only care about 3 and 5 in this example. So okay, so we've got if the number is divisible by 3, print fizz. Else print current number. So we've just got part of this together, but let's run it and see how it changes. Okay, so we've got some fizzes. Now, what we've actually started at is 0 here, and anything divided by modulo 0 ends up being 0. So I'm realizing we don't want that first fizz. So I'm just going to change it here because I know my output doesn't match what I'm looking for. Given 10, we start with 1, and we've got an extra fizz here, so we know we need to get rid of that. But we've got fizzes in all the rest of the right places, right? These fizzes match those fizzes. Okay, so now it's time to upgrade and just ask another question. In Python, if you want to ask 2 questions, you can go elif, and that way it'll ask the first question, and then it will ask the second question. And then if neither of those questions were a yes, it'll go on to the else clause. So elif current number modulo 5 is 0, using that same structure from our primes statement, print buzz. Okay, so let's run that and see if we get our fizzes and our buzzes in the right place. Looks right. Great. Seems like it's matching our 10 output. Okay, so right now we have something that works for up to 5 and up to 10. Let's check to see if it works for up to 15. I'm just going to change that 10 to a 15 and hit run again. Okay, so we're not getting the exact right output. Now let's check out why. So we know fizz is actually supposed to be FizzBuzz, but we've only got fizz. Let's look into why that might be happening. What I'm going to do is I'm going to open up Python Tutor. I like to watch this stuff execute just to make sure that I know what's happening. I'm just going to copy this and paste it here. Then I'm going to click Visualize Execution. And we're going to go step by step. Okay, so n's 15. Now the current number is 1. We've just checked these two steps, and it looks like neither of them were true, so we're heading into our else clause. So then we print 1. Okay, cool. Now it's asking to see if 2. Nope. And now it's asking to see if n is 3. And so if current number modulo 3 is 0, and we'll look, and it looks like the answer is it is, and so it prints fizz, and then it goes back to the start of the loop. I'm going to unclick this. Now, I can kind of go through here and look at 4, 5, 6, 7, 8. Cool. Now let's go to 9. Okay. Let's keep going through. Current number is 11, 12, 13. Now we're about to get to 15. So, alright, not 14 isn't. Print current number, okay. Now, let's watch what happens when when the current number becomes 15, and we have to ask questions about it. We've advanced the current number, and now we're on this first question. If current number modulo 3 is 0, and now this is true, it evaluates to true. So what happens is we just go here to fizz, we print out fizz, and then we're done. We move on to the next number. And so we've exited the function at this point. There's no more steps to do. So the return value is none. So that tells me that what we need to be doing is checking to see if it's divisible by both before we check if it's divisible by 1. Otherwise, it'll be divisible by 1, and so then we'll never check to see if it's divisible by both. Okay, so that means that I need to turn this into an else if. See how I did that there? So now I can write an if statement here. What I'm going to be using is Boolean logic. We're going to use the AND operator. So if current number modulo 3 is 0 or is equal to 0, and current number modulo 5 is equal to 0, print FizzBuzz. Let's run it. Alright, we got our FizzBuzz at the end. Let's see. This is saying end of file error. Let's check that. Make sure that we don't get that every time. Alright. So, as you can see, I kind of experimented my way there. I printed everything out when I just checked to see if the first structure was working, then I added 5, and then we walked through it, we reviewed it to make sure that we understood what was going on. Then we took a look, and we finally finished our last condition here, where we have FizzBuzz. Alright, so that's the UMPIRE process for solving FizzBuzz.